So, welcome, folks. I have started the recording for today's lecture. This is Design 330. It's Thursday the 4th at 10 a.m. We're on a live meet, and we're going to go over today the topic of assemblies. And what we're going to cover are the base designs of your component parts and turning those into the specific designs you need to make this assembly. All right? So that's what we're going to work on here as we go. I will be working on VMware most of the way. Let's see, I've got some stuff up here. I've got some files available, and I've got Inventor open. So I think I'm set, and I have my work ready for 2/4/21, and I've got Adobe ready, and I've got everything up and running. So I think I'm set to start doing our demonstration for today. So let's first of all talk about, again, the process we go through. You got a bunch of parts that are just generic. It's like having a generic drug or a generic product, and it's not specific enough. It's got the stuff, but you don't have one of every size. Okay? And from these base design parts, you're going to make specific parts for this design. And last week, you looked at the design and you looked at all the different parts. That was what last week was for, was so you could become familiar. Oh, what's a 1/4 inch nipple? What's a 1/2 inch nipple? What's a coupler? What's a bushing? So at this point, you should have an idea of what these are, so that when I say, okay, take your base design and make a 1/4 inch nipple, you should be able to look it up from your stuff and get to it. So that's the concept and the idea. Once you've got the ones specific to this particular design, you can make an assembly of it. Okay, so let's take a look and see what that assembly actually looks like. And I think I can do that over here in my VMware because I've got it up and available somewhere. Maybe I don't. Let's take a look at right here. So this is what the design looks like, right? And we're just going to review it really quickly. There's a base block. There's a short nipple and a short nipple. And then there's two check assemblies. One check assembly screws right into the base block. The other one screws onto the nipple. Now coming sideways out of the base block, you've got a nipple that attaches to a bushing, which attaches to a coupling, which holds the piston pipe, and the piston goes inside of it. There. That's what we've got right there. So I need 1, 2, 3, 4, 5, 6, 7 specific parts. Now this particular nipple is a 1/4 inch nipple because it fits the 1/4 inch female end on the check assembly. This one is 1/4 inch, so it just goes right in. This one I made 1/4 inch just so that I could make my base block real simple. I could have really simplified this, of course, but that's for a future week by putting this straight into here. But that's an advancement on the design that you may make in the future. Let's see what it looks like in the cutaway isometric. That's what it looks like. And the water goes in over here. When I push the piston down, it flows out over here. When I pull the piston up, it flows in. And when I push the piston down, it flows out. Okay, hopefully that all looks familiar in some way. It's supposed to look familiar. So let's look and see. Now, if you do not have the parts ready, I've got them for you. I'm just such a nice person. The engineer has made the base component designs for you. Base design. And there's the parameter file. Base design for the bushing. And there's the parameter file. Base design for the check assembly and the parameter file. Base design for the coupler. Base design for the nipple. And base design for the piston. So from these base design files, you can go get it. Now, you're supposed to have been able to make these all. Okay, you kind of had 3 or 4 days, and they're fairly simple to do, to model. I actually made all these base models starting at 7:24 this morning, and I was totally done all the way through my assembly by 8:49. So a little over an hour to make these base designs and do that stuff. So the idea is that you're supposed to develop fluency and quickness, and that you should have had these done. So if you have to use mine, and look, mine are not always perfect. I rushed these through. It took me a little over an hour. So if you see something that goes, oh, then fix it. Okay. Okay? Because I tried to get them done really fast this morning so you would have one of everything. If you use one of mine, you have to say so in your presentation. Now, from these, you can make everything. From this nipple base design, you can make a 1/4 inch nipple and a 1/2 inch nipple. And from this coupler, you can make a 1/2 inch coupler. Your check assembly, the base design is actually the real design. And the piston, the base design, is the real design. So you don't have to worry about those too much. Okay? But there you go. So let's see how that works. I've got them all here. I've got all my base designs right here. And I'm ready to make a sample design. I went through it this morning and did all these. But I'm going to kind of do it again just to show you how the process goes. So the first thing I need to do is make a base block. So I'm going to make a copy of that. And I'm going to put it in my sample design here. And I'm going to rename that right now. Rename. Oh, I didn't rename it. Darn it. Did that wrong. I'm going to right click and rename that. And this is my 2 by 2 by 2.25 NPT female. So that lets me know which base block I'm going to do. So let me open that up and see if that's what it is. I'll see if that's what it is. Because if it's there already, I don't have to make any changes. Okay. 2 by 2 by 2. It's in my parameters already. 2 by 2 by 2. Through hole diameter. I'll have to go look at those and see what they say. Let me just see what they say. That one says it's a 1/4 inch NPT. That one says it's a 1/4 inch NPT. And this one says it's a 1/4 inch NPT. So I really don't have any changes to make to this one. I just had to rename it to what I wanted it to be. And it just turns out that that was right. 2 by 2 by 2 with 1/4 inch NPT female. So now I need a 1/4 inch nipple on one side and a 1/4 inch nipple coming out of the top. Well, let me go find those. 1/4 inch nipple. base designs, nipple standard base design. I'm going to copy that and I'm going to put it in my new one here. Paste. And I want this to be 0.25 NPT male short. Now I happen to know these dimensions, so then I'm okay. A 1/4 inch NPT has an outside diameter of 0.54. Okay, so let me do it. 0.54 outside diameter. And an inside diameter of I think it's 3.6. And my length is 1.33. That's what I happen to know. And these I've got to go change my thread. Double click. I need to change it to a 1/4 inch NPT because that's what I want. There, I've got my 1/4 inch NPT nipple. So that's a nipple, 0.25 NPT male, threads on the outside, short. Save. And I'm going to use that a few times in the design. And I happen to know the next thing I need to do is put my check assembly on it. So let me find my check assembly base design. And there it is. There's my check assembly. It doesn't have any internals or anything like that. But I did put an arrow so I know which way it's going. Let me look at the parameters and see if it's right. It should be 1/4 inch NPT. Yep, that's what it is. 0.5. That should actually be 0.54, I think. 0.54 with a 0.36 inside, 0.5 long. Width across the flats, that looks okay. Taper, and now I got to go see what these threads are. 1/4 inch NPT. Oh, that should be a 1/4 inch NPT. It's 1/4 by 1/4. There we go. So now I've got this one and I need to save it as. I didn't rename that one. I should have. File, save as. Check assembly. 0.25 NPT female inlet by 0.25 NPT male outlet. So now I've got that part. I'm just going part by part. So now I have my block. I have a nipple. I can screw my check assembly into it. Remember, I need to, right? So I've got, let me make that stay up. I've got my block. I've got my nipple. I have my nipple. I have my check assembly with a 1/4 inch NPT inlet and my check assembly 1/4 inch NPT for the outlet. Cool. So now I need a bushing, a coupler, and my piston pipe, which is a nipple. Okay. A bushing. So now I need a bushing. Let me take that base design and copy it and put it where I want it. And I'm going to rename it to what I want it to be. This one's going to be 0.25 NPT female because I'm going to screw into it by 0.5 NPT male. Because that's what I need. So that helps me understand what I have to do here. So I don't have everything on here even, but that's okay. So I can go to my parameters. NPT female ID. Yep, that's a 0.5. That's a 1/4 inch. And a 0.84. It's already set right. 0.84 is my OD of an NPT. And you need to start remembering these dimensions. So now I can put a thread on here, which is an NPT, and it's a 1/2 inch. And I can put a thread on here, and it's an NPT, and it's a 1/4 inch. So you can see, because I know my numbers, I'm starting to get it down. And that's why we were doing those tables and looking things up and kind of drawing them and having it all available. So most of this is 1/2 and 1/4 NPT. And so it should get sort of set after a while. So now I've got it, though. I've got my coupler, and it's pretty easy because I had my base design. Bushing, 1/4 inch NPT female by 1/2 inch NPT male. Save. And I'm just putting things together. That's all I'm doing. So now I'm going to have a coupler on here. So let me find my couplers. Going back and forth again. Base designs for a coupler. Coupler. Standard base design. There it is. Okay, so that's what it looks like. So let me move it, or copy it. Right click, copy, go put it in my sample design folder. I'm just gathering everything. And this one is going to be a 1/2 inch. 0.5 NPT female. So what's the inside diameter of a 0.5 NPT? 1/2 inch NPT ID is about 0.622. Okay, so let me come over here. My coupler OD, coupler through bore. Here it is. My through bore, 0.622. Oh, no, actually, I take it back. So what has to fit in here is an NPT pipe. So it's going to be 0.840. 0.84, I should have known that. There we go. And then this OD of 0.92 looks okay. And my hex is on there. And I really don't care about my lengths too much. Now I've got it. Thread 1, thread 2. Let's make sure my threads are called out right. 1/2 inch NPT. 1/2 inch NPT. So now I've got my coupler, 1/2 inch NPT. Save and close. The next piece I need, so I've got my base block. I have a 1/4 inch nipple, a 1/4 inch nipple. I've got a check assembly. I've got a check assembly. I've got a bushing. I've got a coupler. And so now I just need my piece of pipe that I'm going to use for my piston bore. And that happens to be a 1/2 inch piece of pipe. And it's a nipple. And it's about 3 inches long. So those are the things I remember. So if I come over here from my base designs, I'm going to go to my nipple standard base design and make another copy of it. Copy. Paste. I'm going to rename it. And so this is a 0.5 NPT male. And I think I want it about 3 inches long. I can change that later on, but I think that's what my design actually is. Let me open that. And we're just going to check it out through the parameters. 0.5 NPT, so I got that right. It's 0.840. This ID is actually probably 0.622. It's already 3 inches long, and it's saying it's half-inch NPT. I'm going to check this thread and make sure. Yep, half-inch NPT, half-inch. There, I got that one. Save. And of course, my last one is the piston, which we haven't done a lot of work with yet. The piston just is correct already. So you can use your piston-based design and copy it. So there we go. Hi, Wasan. Your microphone's back on. There we go. Cool. So here we go. Piston, copy, and I'm going to go put this over here. And so here's the idea, and Wasan nailed it. So there's the piston. You're supposed to have drawn those. You're supposed to have made those and modeled those. That's in the assessment, pre-assessment for this class. I gave you an exercise that was basically this complicated for, that's okay, for you to be able to model. And so my expectation is that you can make these models in AutoCAD, Inventor, Fusion, whatever it is that you're going to make them in. I'm showing you parametrics because that's the world that we live in. And you can do parametrics with AutoCAD, Inventor, and Fusion. It's just easiest in Inventor. It's easier. But you should have had all of these already. All of these base designs already by today. That was the assignment. Have all of these by today. And what I've given you, if you don't have those, you can use mine. You still have to go through and make these. Okay, so you can look them over. And you should fully understand how they go together. This is, week 2 of working with nibbles and bushings and couplings and NPT threads, male and female. And so should start getting a feel for those. If you don't have a feel yet, study these tables, look them over, find out what they mean. What does the F mean, female? That means that there's a thread on the inside. What does the M mean, male? It means there's a thread on the outside. So you should be able to develop these. It took me about 15 minutes to develop these from the base. And that's the whole idea behind having a base drawing. If I wanted to make a whole different one that was 4 inches with 3/4 inch stuff and 1 inch stuff, I should be able to do that in about 15 minutes. So this lets me make my design. Okay. So now that I've got these though, it's time for me to make an assembly. And this might be somewhat new for some of you. If you've had 328, you know how to do this. If you've had 310, you probably know how to do this. If you've had 302, you probably know how to do this. Okay, but I'm going to show you. And one of the reasons I picked this design is it's real simple to assemble. So here we go. I'm going to make my assembly. A new, and I'm going to just pick a standard assembly, IAM, standard assembly. And I'm going to create it. And I'm going to just start putting parts in. And so when I put a part in, I place it. I place a part, and I have to go find it. It's going to be out of my sample design folder. And I'm going to start just like I looked at. This is block housing number 1, pink. And I'm just going to put it in there. But guess what? I'm going to rotate it. I just think it works better that way. Where did it go? Come on. I know. This is having a hard time making the rotations. I may have to do it later. Goes. Rotate. I don't know why the rotate is not working for me right now. There it goes. One's in there. I'll delete that one. So now I've got, if you look at it, I've got it going like that. Okay. And so now I know that the next thing is there needs to be a pipe nipple on the top and a pipe nipple coming out. I know that because I've studied this. So I want my 1/4 inch NPT nipple, short. There it is. And I don't care in this case what the orientation is. And I'll show you why. This one, I'm going to screw this end in over here. So how do I do that? I make a joint that is cylindrical, and I put that center line on that center line. And it goes and does it for me. Now, the only problem is it just sort of stuck it on the face. So I need to go here and double click and say, well, where do I want it? I want it about another 0.223. I'll put it in a full 1/4 inch, 0.25 inches inward. There, now it's stuck it in there. And check this one out. This will be cool. Now I'm going to take this one and do a joint, and I'm going to make it cylindrical. Oop, got to get the right one. Cylindrical. I'm not doing well here. Cylindrical. And I'm going to put, again, that point right there. And it's going to go, oh, isn't that the coolest thing? So that looks okay. But again, I need to take that joint and I have to move it 0.25. And you can go to your tables and find out exactly how far they go in. So now I'm getting my thing made here. I'll go back to my front, come over here. And so now the next piece to put on are my check assemblies. And one screws directly into here, and the other one screws onto here. So I'm going to place my check assembly, 1/4 inch, female inlet. Okay, that looks right. That's the one I want. I'm going to want one here and one over here. Okay. And this one, I'm going to, again, screw in with a cylindrical joint so that that center point matches up there. And again, I have to open it up here, and I have to get this cylinder, and it has, see the arrow is pointing which way is plus, so 0.25. And then I'm going to take this one, and I'm going to put it as a cylinder. This is why I love making things out of pipe. Everything's cylindrical. It's the easiest joint there is to make on Inventor. There we go. Apply. And now I can take that cylindrical joint, 5, and my flow is going from right to left. So now I got to get a 1/2 inch pipe on here. So I need, yeah, this is, Wasan goes, this is really cool. It is. And this is the cool part about using these parameters and having this. I can make any number of these very quick, and I can see that my check assembly has a problem, but I'll fix that later. See how it's not matching up with the, I made my pipe the wrong size, but I don't care about that. I'll fix it later. Okay, and I'll show you how to do it. And I actually did it wrong on purpose so I could show you how these fixes work. So place. Now I need a bushing. 1/4 inch NPT by, there we go. Now this one, I'm not going to bother to rotate it because it'll rotate when I stick it on there. Okay, so I'm going to do a joint again. Cylindrical is getting boring. Right on there. Oh no, it's upside down. It went on the wrong way. That's this little flip it over button. Flip. Oh, that's much better. Whew. Come back to this view. They don't have a very good view tool, but that's okay. And now I got to put that one on 0.25. And the reason these are all different is you get to tell how much thread sealant, how much pipe tape, how much tightness there's going to be. So you get to play with these. All right, my next one is I need a 1/2 inch coupler. Coupler 1/2 inch NPT. Put it in here. Okay. Joint. This is getting quick. Cylindrical. I don't care which end I put on. Went on the right way. If I got the wrong one, I'd just flip it again. Apply. And I'm going to put it in 0.25. Oh, wrong way. See how it went the wrong way? Minus 0.25. There we go. And now finally, I need to put in my 3-inch long 1/2 inch nipple that is my piston tube. Okay. And joint, cylindrical. This one's going in backwards too. So I'll flip it, apply, cancel. And I think this one is also going to be a minus 0.25 because the arrow is going the other way. There. So I've got everything but my piston now. And it's starting to look like the piston pump. This is so cool. So now let me find my piston and put it in. There we go. And I'm going to put another cylindrical one. That's the beauty of working with pipes. And I'll put this top end right there. And of course, it really has to be inside, right? So I've got to figure out how far I want to show it. And there's lots of things to do to make it movable. Oops. I'm going to go minus 1 inch. Oops, I have to type it in here. There it is. Now it's stuck in there part way. So I have my part. Save. Right? So what is this one? I can do a file. Save as. In my sample design. And this is going to be my sample piston pump. Oops, I'm typing with my cap locks on. Let me do it all that way. Sample piston pump assembly. And I'll put the date on it just so I come back and redo these all the time. When I look over here, there's my sample, and it's got, see how it's got these 3 little boxes that say I assembled some parts. That's why it's an assembly, and it's an IAM file. Part files and assembly file. Okay, so now let's go back to see what we were supposed to do. You can use my files. You can use my base design files and do that, what I just did. I'd prefer if you use your own base design files and that you use your Excel parameter tables so that you know what those dimensions are. I've done these so often, I just know them, right? So I was able to type them in. The parameter tables are there so that you can look up the dimensions that you want. Yes. So Alex, yes, I do have the recording on. So that's a It's like, woo, huh? Be sure, are you recording this? Yes. Okay. Um, so use your component tables from last week or this week or anything, right? Find the tables, find the dimensions, have them handy. Know what you're doing. If you're just copying my videos and just typing in the numbers I tell you, you are not learning the design process. You need to be able to figure these dimensions out yourself. Okay? And then, so you use these base design files, you make a new one, and these are the ones you need. You need the base block 2x2, short nipple, 1/4" NPT, check assembly, 1/4" NPT, bushing, 1/4x1/2, coupler, half, nipple, 1/2x3 long, and piston. Those are the parts. Now, I've left off the O-ring and the spring because I'm not worried about those right now. They're not really going to be, they're part of our design development next week. All right. So now, make an assembly drawing that looks like mine. So you assemble it using the joint, cylindrical, and offset commands. And then in your drawing, I want a top view, a section view, a section ISO view, item bubbles, part lists, and revision info. And that just pops out pretty darn quick. I'm going to show you right now. So I've got this thing saved, and I'm going to make this full size on here. Here's how you do it. You can go up to make and all that kind of stuff, but I'm just going to right click on this and create a drawing view right from my file. Click. And I use an IDW because this is an inventor, so I'm going to use an inventor drawing. You can use AutoCAD, but I'm going to use that. And I'm going to use this big one. I'm going to use a big D size one. I could use a C size, which wouldn't be too bad either. But I'm just going to make it easy on myself. Later on in the course, I'm going to tell you how to play with these sizes. I'm just going to make it easy. I'm going to take that first one, click, and I got a huge sheet, a D-size sheet that's like 24 by 36. But I want, not my front view, I want my top view as my base view, and you'll see why in just a moment. And because I'm on a big D-size sheet, I can make it 1-to-1 scale. I got my top view, 1-to-1 scale, click. And there it is. It's there. And that's how I get my top view. My next thing is to make a section view. It's under the place view tabs. A section view of, I see how I highlight it and it kind of pops on. Click. And then I have to say where my section goes. So I find a midpoint. You may not be able to see it on your screen, but it's drawing a little dotted line for me. So I'm going to come out a ways. Click and click. That's going to be where I cut my section. And you should know about that from Design 302. Right click, continue, and place my section view. Oh, that is so cool. Look, now I don't care about this interference. I actually like it. It tells me I have threads locking together right there. It's a good thing to see this interference. And later on, I could even use it to do some analysis. Now, I'm not sure if you learned, but you were supposed to have at least seen that if you make a section view that is from a principal view, you do not need to label it if it's lined up properly. So I'm going to double click on that, and I'm just going to, you have to have the thing there, but I'm just going to backspace it so it's blank. I do not need to call that out. It is understood. And I don't need this big old line. So if I right click, I can get rid of show entire line. There. Now my drawing is cleaning up. Now, I said I wanted an isometric view of a section. So I'm going to make a projection of my section, and I'm going to flip it around to turns it. There it is, isometric. And it's in the wrong place, but I can move isometric views. Click, right click, create. I now have an isometric view, and because it's an isometric, it lets me move it around wherever I want. So I'm just going to put it over here. And I'm actually going to edit that. I'm going to do a little bit more than I showed you in my sample. I'm going to make this scale. Not going to let me change my scale. Really? Oh, that's interesting. It's not letting me change my scale. Too bad. I thought I could. Anyway, so here I go. I've got it. I'm going to move it over.
Start view?
Yeah, well, when I do my edit view, the scale button. Oh, here it is. Click that. There it is. So now I can go 2:1. Did that go the right way? Yep. Now I got a great big view of it. I had the selector hit. Because that's the main view that I want to see. I want to see that thing, and I want to see it big, and I want to be able to view it. So in your portfolio, you're going to show top view and orthographic section. And on another page, you're going to show this. And then I want to see bubbles. That's under annotate. Item numbers. I'm going to balloon this view, and I'm going to select all the parts. And now look, I can make it ignore multiple instances so that it only points at one nipple as an example, or I can make it do all of them. For this class, I don't care which you do. We'll talk in detail about that later on. Okay, and we want parts only, numeric. I'll leave it as parts only. Bill of material. I have to select the placement. So this puts them all horizontally somewhere. This little button places them vertically somewhere. And this one places them all around. I think vertical is going to be a nice selection for you. And I'll show you how you move them around in a little bit. And you can change all these balloon shapes and things like that. I tend to use standard balloons. And if I click, see how that does multiple instances? I'm going to leave that simple for right now. There we go. So now I've got one with item numbers. Now, it doesn't look really great yet because it's hard to tell what that's pointing at. I'm going to move that dot so that it's real easy to see, and I'm going to move this one up. This one's pretty easy to see. This one's pretty easy to, this one's not easy to see. I'm going to move it down here. And I'm going to move this one down where it's a little bit easier to locate what it's looking at. And same with this one. See, it's like, okay. I want them to be much more visual. Okay, and notice it's only calling out one nipple, even though, so if I want to call out all of them, I'll do the other one. I don't care for right now. I just want to see some bubbles. I do not care. I want to see some bubbles. So there is an isometric view, and it's one with item numbers on it. And that was from the auto balloon. And now I'm going to put a parts list in. And I'm going to parts list that view. And I don't really care. We're going to look more about how to structure the parts list later on. But I do want you to make it so that it's big enough so that you don't have some of these weird things like that. I'm going to maybe line that up right like that. There we go. Now I have a nice looking one. Cool. So now I've got all my parts. Inventor likes to have it up here because the bill of material goes in this direction. You could do a mirrored one, but you always want to have room for more at the bottom. So I'm going to put the bill of materials in the upper corner. Often I do the opposite of that. And I'm going to put my revision block, click, right down here. And I'm going to get it set so that the description is a little, oops. I want my description to be longer. They have these so they kind of go backwards a little bit. It's kind of a booger. So there. That lets me know what revision this is. And we're going to talk more about that later on too. That's what I'm looking for. If we check it out, did I get everything? Top view, yes. Section view, yes. ISO section view, yes. Item bubbles, yes. Parts list, yes. Revision info, yes. So, if you are used to doing these, you can see this whole thing is about a 45-minute process. I think you might take 2 or 3 hours. Okay? So that's cool. Take your time, get them right, but be sure you understand how to make each one of these right. Oh, now I have to go back and show you. I got something wrong here. When I zoom in, what? I got something wrong with this dimension. So I'm going to have to go fix that thing. So let me go fix that check assembly. That's probably my extrusion number 2. Sketch 840. Oh, this is the wrong one. I'm on my bushing. Sorry. Get out of this. It's my check assembly. So let me go find my check assembly. There's my check assembly. Let me look at my parameters. Well, it's, gosh, that's my outlet. Inlet. Where's my inlet? 0.62. That should be a 0.54. There. Got it. Isn't that the coolest thing? I can go fix it. Because I noticed that through all of my parameters, I had something wrong. And that was one of my dimensions that's wrong. Okay, so now I better save this. It's going to say, do you want to save that? Yes, I do. And now when I come back to my drawing, it's right. It's got fixed. And there's a little flashy thing up here that I go, click, update it. Yep. Now everything's locked in and updated. Now you may wish to do a little bit more work. A lot of times people will put an overall dimension on something. And if you do so, it's just a reference. It's not a dimension that you have to hit. It's a reference. You put it in parentheses. This whole thing is about a little over 5 inches long. And it's a little over, and I'm going to go to there. The main body parts are a little over 7 inches tall. So that's commonly done. Okay, so there we go. That's your file, and of course you'll save that. Sample design, sample, go, and it's an IDW. So I have my assembly, and I have my piston pump drawing. That's where we're getting to for this week. Okay, so I'm going to close Inventor right now. Does anybody have a specific question? That was just a demonstration and show you how to do what to do. Okay, I'm going to close this down then. Close. Close. Make it small, and I'm going to look again at what we did. I go over it again and again and again. This is all about how do you make an assembly. You make an assembly out of sort of standard base parts that you kind of know about. And for the assembly that you're making, you fix them up to be the exact dimensions that you want. And then you put them together. And since we're using all round pipey like things, you just use the cylindrical joint. And then to stick them into each other, you use the offset. And then when you make your drawing view, these are the things that I'm interested that you know how to do. Okay, so here's the grading standard. I want to look at this so that you know kind of what things might look like here as we go through it. Okay? So if you get all the work done, you made the base drawings, you made the piece part drawings, you made the assembly, you made the DWG, you got a parts list, you did all that, and you did your research, you'll be in the 3.6 to 4.0 if all of your work is pretty good, meets all of our technical standards. If you did most of it yourself, maybe you needed one or two of my base designs or something like that, and most of your work is looking like it's pretty technically correct, but you got a few items. Maybe you missed, like I did, that inside diameter, and it wasn't quite right. And maybe your research was missing a few things. You'll be in this range, 3.2 to 3.5. Okay? If some of your work, if like you used all my base designs and then some of it still didn't quite come out right, and there were some problems here and problems here, and really even some of it was wrong, and you might have even missed one or two things maybe you didn't get the revision block, or maybe you left off one or two of the research things. You'll get a grade in this range. And look, if you got one or two things right and looks really good, and then a couple of them were okay, and then some of your work really didn't quite make it, and there were some things missing and even more not complete, you'll get a grade in this range. And this is for, substantially just not right or a lot missing. So for this week, you do not need the springs and the O-rings. So Wasan asks, you're not sure what you need out of the purchase parts and the springs and the O-rings. You don't need them this week. I was going to model them for you and haven't done it yet. So you could just say, this section left blank for your models. Okay, I'll have those for you next week. And well, actually, let me just show you really quickly. And here's why I'm not as concerned about it. If I make an assembly, and I go up into my design thing, all the O-rings are in there. I can just place an O-ring. And I just go to my content center and I browse for an O-ring and I just put it in there. They're all there. Look at all these different standards. Where AS pneumatic dynamic. Oh my gosh. They're all in here. And so I can just look at which one I want to I can just click in there and oh, there's the one I want. I want that one. Right there. Shaft diameter 0.562. And I need to have a surface to be able to put it on and stuff. But the O-rings and the compression springs, they're already in there. Isn't that cool? So if you're using Inventor, I've sort of so the fittings, the bushings, and the adapters, that's where you'll put your nipples, your couplers, your bushings, pipe pieces. So that's where those parts will go. Okay, so those are good questions. So that's what you want. You want to get everything all in there as much as you can. All right, but I want to be clear. This one is a lot of work. It's hard to get this range, right? And look, if you're kind of in between these, you'll probably get a 3.5 or a 3.6 or right. But look this over. This is how everything gets graded, and you should know. And then you go, oh, woo. I'm okay in here. That's still a really good grade, by the way. That's a really good grade. This is a passing grade. Like you learned everything. That's a good grade. This is you learned everything and did a pretty good job. This is like, wow, that's really cool. So all you need to do is get in here. So look, just know, make your decisions. I know some of you can't do that. It's like I gotta get here. I gotta. So, but that's hard to do. There's a lot of work, and there's tons of stuff. Okay, so there we go. I'm gonna stop the recording now.